Right. Assalamu alaikum. So today I would like to give a general tips or a small information for what is related to properties of waves. Um, more specifically, I would like to answer a couple of questions that sometimes appears in the past papers. Sometimes they can give you a generic wave such as this. So this is the um, uh, maximum displacement or the displacement from the origin, and sometimes they draw a wave like this. Right. So as you know, wave is a kind of repetitive motion. So it is a motion that it repeats itself. It goes up and down again and again, right? So there are a couple of things that we would like to define. Amplitude is the maximum displacement from the rest position or the rest line. So now, so this is, I wanted to ask this question. Sometimes they can give you this distance from here to be, for example, 4 meters. This is measuring the vertical displacement. And sometimes, and also they can give you this distance from here up to here. Let's say here, for example, this, let's say 12 meters. This is the horizontal displacement. And similarly, they can give you in this axis, instead of distance, they could give you also time. And let's say time is being given up to here. And let's say this is given to be 10 seconds. So it would ask you the following questions. So find the amplitude to the wavelength three. They can ask you to find frequency. 4, they could also ask you to find the period or the periodic time. And finally, they can also ask you to find the speed of the wave. Right. So in order to answer this kind of question, we need to know the definition of each. The amplitude is the maximum displacement from maximum vertical displacement from this line here, which divides the wave into two halves. This is the upper half and this is the lower half. Since he's giving you the distance between, this is called the trough, and this is here called the crest, this point here. So since he's giving you this vertical distance to be 4 meters, but I'm interested only in the amplitude. So the amplitude could either be this or this distance beneath here. So since the whole of this is 4 meters, means that the amplitude A is equal to 4 divided by 2, which is 2 meters, which is only half this distance. So I'm only interested for the distance from here up to here, or from here to here, from the rest line to the trough, or from the rest line up to the crest. Now we would like to find the wavelength, and to find the wavelength, to answer the second question, we would like to see where does the wave start. It starts from here and it completes a full oscillation. So this is one oscillation. This is one full oscillation. This is the first one, and then it repeats itself again and again. Why is that? Because we are starting from here. So again, a point like this would be the second one, not this one, but this one here. So this is the first wave, this is the second wave here, ends up here, and the third wave should be ending up here. But we notice that he's giving you the distance up to here. Now, if we just let us take this wave a little bit like this here, let us draw it here. Now, this is the full wavelength, right? Now, if we take it, if we divide it into halves, that means from here to here, this is full wavelength, lambda. But if I take it from here to here, this is half of it, so this is half lambda, and this is the other half. But if I take it from this point, from the initial point here, up to the crest only, this is a quarter lambda. This is a quarter of the wave, 1/4 of lambda. So if you notice, this is not even completed a wave, and it's not a half wave, but it's a quarter. So what I would say, so this is one wave, two wave, and not a half, but 3/4. Why is that? Because this is a half lambda, and from here up to here, this is a quarter lambda. So this is in total from this point to this point up to here where he stops, this is equal to 3/4. The whole of this is 3/4. So this distance is 3/4 lambda. So what I would say, in full, the 12 meter is equivalent to 1, 2 waves and 3/4. Let us get back. So 2 waves and 3/4, 3/4 lambda is equivalent to 12. Then we need to work out this and find lambda. So we express this as a fraction, a proper fraction. So 4 times 2 is 8, plus 3 is 11. This is 11/4. Lambda is equal to 12, which means that lambda, by making it subject of formula, lambda equals 4 times 12/11, which is 48/11 meters. Now, how do you find the frequency? Similarly, we count the waves, because frequency is defined to be the number of full oscillation per second. So we would like to see in this 10 seconds how many waves do we have. So again, we continue counting. This is 1, 2, 3 up to here. Again, it has not completed the fourth one, but a 3/4. So 3 and 3/4. So 3/4. This is being completed in 10 seconds. Now the frequency is defined to be the number of full oscillation, which is this number, 3 and 3/4. 3 and 3/4 of the wave. This is the number of full oscillation divided by 10. 3 and 3/4, this is equivalent to 12 plus 3, this is 15. 15/4 divided by 10, this is equivalent to 15/40, and the frequency is counted by hertz, or second minus 1. So this is the answer for the frequency. Now, what is the period? Which means the time enough for one oscillation. This is in fact the reciprocal of the frequency. So the periodic time, which is the time for only one oscillation, is equal to 1/f. And that is equal to 40 divided by 15 seconds. Why is that? Because hertz is also in, you can express, instead of hertz, you write s minus 1. Now everything is being worked out. Then you can work out the speed, and you use the wave equation, which basically tells you that v is equal to the frequency times wavelength, and you have the frequency, which is known to be 15/40 hertz in SI units, or second minus 1, multiplied by wavelength, which is this number here, which is 48 divided by 11, and then you just need to simplify this by 4, 1 by 4, 12, and multiply it out. So it is 15 times 12 divided by 11. You work out the number with a calculator and you get the answer. And the answer, since this is given in hertz, this is given in meters, so the answer, what you get out of the calculator when you multiply this out, you get the answer to be meters per second. Thank you.